Hey guys, what's up? This is ETSki Tutorials and this is FPS 1.5. In this episode we're going to be learning the basics of jumping. Now you may be thinking to yourself, oh, jumping, that's easy. All I have to do is write if input.getButtonDown jump rigidBody.add force jump velocity on the y-axis. What that would do is every time you press the space bar is it would add, jumping acceleration to your character, and he'd go like wee and make like a jumping motion. But the only problem with that is that there's nothing to stop you from double jumping, like jump, where that's not realistic at all. There's no physical way of jumping in the air and then midway in the air jumping again. I would know. There's no physical way. I have tried it. There's no possible way to jump and then jump again without touching the ground. You just can't do it. But you can just do more than double jump. You could triple jump, you can quadruple jump. You can just keep on jumping until you fly into outer space, if you were to put an outer space in your game. But in our case, you would just keep on going higher and higher up in the air, because you're going to still have the same skybox no matter where you are. But that's completely irrelevant. The point is that we need to detect when the player's feet are touching the ground, and if that ground is flat enough for us to jump from. So you could probably jump from a surface like this, or you could maybe jump from a surface like this, but there's not much conceivable way that you could jump from a surface that is like this sloped. So we're going to put in a little bit of code that's going to stop you from doing that. But more than anything, this is going to be how to detect if the ground is beneath your feet, and then if it is, allow the player to jump. Alright, so let's get started. Here's the variables that we're going to be working with today. So we have these three main variables, and these are going to be our variables that are going to be visible in the inspector. Or at least these two are going to be visible in the inspector. We're going to hide grounded in the inspector because that's something that we don't need to edit. But max slope and jump velocity we will need to edit. So let's get started. We have the first one is grounded, and that's going to be a boolean. And a boolean is a true or false variable. So that means if our feet are touching the ground, grounded is going to be true. If we're up in the air or falling in the air and basically our feet aren't touching the ground, grounded is going to be false. And that's the variable that we're going to use to keep track of whether or not our feet are touching the ground. The next one is max slope, and that's a float. And this is going to be measured in degrees. So basically, ground like this would be 0. Ground like this would be 45. Ground like this would be like 80. So max slope is going to be the maximum slope that we can jump from. So we can determine if the player can jump from something that's at a 45-degree angle, or if we want to, like let's say we have a game where you're a frog and you have really sticky feet or something like that, you can jump from a surface that's at like 80 degrees, but you're not going to want to go more than 90 degrees because that's straight up and down, or 180 degrees, which would be a ceiling. You can't jump from a ceiling. That doesn't make any sense. So we're going to have max slope, and then we have jump velocity. And this basically is the velocity that we're going to add to our character to make them jump. So basically, how high we're going to jump. So the two factors that are going to affect how high our player jumps is jump velocity and gravity. In gravity, you're going to edit in the inspector under the physics engine. And then I guess you could also affect the mass of our character, which is default value of 1. But anyways, so jump velocity, gravity, and the mass of our character are going to be the three things that are going to affect how high our player jumps. Okay, and now we have two variables down here that I just thought I'd list them off just because they are variables that we are going to save, but we're not going to save them outside of the update loop. Well, we are going to save them outside of the update loop, but we're not going to save them outside of a function. So they're not going to show up in the inspector, and they're not something that we need to edit. It's something that the code is going to use and go through. But basically we have collision, and that is a variable type of collision. I'll explain that later. And contact, and that's a variable type to points. Once again, I will explain that later because it's kind of tricky to understand, but you need these two variables in place for us to detect the ground beneath our feet. Alright, this line of code here basically is saying if the space bar is pressed and we are touching the ground, jump in the air. So let's go over how exactly this works. So we have if input.getButtonDown jump. So we're using input, we're accessing the input class. GetButtonDown, and we're using GetButtonDown instead of just plain GetButton, because GetButton is going to return true every frame that we are holding this button down, and we only want to jump once. So as the spacebar goes down, we press it once, and it jumps in the air, and then after that, as long as you're holding it, it doesn't return true. It only returns true the moment we press it. And then jump, which if you open a new project in Unity and you don't change anything in the input menu, jump by default is going to be spacebar. And, which you have two and symbols, which is shift, I don't know which number, shift something, I'd have to look at a keyboard, but the two and symbols, grounded. So we just have grounded because that's a boolean, so no matter what, this variable is going to either be true or false, and we're going to define whether it's true or false later on, depending on the collisions. So we don't really need to put much there. So this statement will return true or false depending on whether or not the spacebar was just pressed, and this will return true or false depending on whether or not our player is touching the ground, but we need to define that later. So if both of these are true, it's going to execute this line of code, which is rigidBody.addForce 0, jump velocity 0. So rigid body, we're affecting the rigid body attached to our player character, add force, and we could use add a relative force, but add force works the same because no matter what in our game, our character is going to be standing upright. So the y-axis is always going to be the same no matter what. So you could either use add relative force or add force. They should both behave the exact same way. And then we have 0 on the x-axis, jump velocity on the y-axis, and 0 on the z-axis, because we only want to affect the y-axis, and we want to go positive along the y-axis. So in the inspector, we will assign a positive value to jump velocity, and we'll adjust it to make it look right later. So, and then we don't need to put bracketing because there's only one line of code. So just the if statement, and then the one line of code, and that is what we're going to be putting inside of the update loop. Alright, this next line of code is going to be pretty complicated, but I'm going to do my best to explain. Basically what this whole thing is going to do is if there's a collision beneath our feet, it's going to save grounded to true. So the first part, we have function on collision stay. So this whole thing we're going to be putting outside of the function update loop. So this is a separate loop, and this loop is only going to be called if there's a collision detected. So we have function on collision stay, collision, collision. So this collision is going to be the variable that we're going to save, because collision is a variable type inside of Unity, because there's lots of different things that we can access through collisions, and the one thing that we're going to access is the normal of the collision. I'm going to explain that in just a second. So we have this, it's called every single frame that we detect a collision, so hence on collision stay, so if it stays within inside of a collision, and we have, it's going to save the collision as a type collision, so this is a class and it's uppercase, and this is lowercase because this is the variable. And then we have an opening bracket and a closing bracket. So all of this code right here is going to be called every frame that we're detecting a collision. So now that we have that down, let's look at what is inside of these brackets. So what we have going on here is a for loop. A for loop basically is a loop that it's going to say, kind of like an if statement. If an if statement is true, it's going to do everything inside of the opening and closing bracket once, whereas a for loop will do it multiple times. And in this case, we have the for loop set up so that it's going to loop through every single collision that we have detected with every game object that we have detected. So, I mean, you're not always going to be on a perfect flat surface. You might be, let's say we have two cubes and they're intersecting each other like this, and you're walking in the middle of them. It's going to have a collision with both of those points. So it has to detect both of those points and go, or not points, both of those colliders and both of those objects, and test those individually. So we have for var contact, and that's of type contact points, in collision.contacts. So here we are, we're using the variable that we have given to us through this function, and one of the variables that we can access through a collision is contacts, and contacts is an array. So this means these are all the different contact points, or all the points of contact that are going on in our collision right now. So this could just be one contact, or this could be 20 contacts. That's why we are taking the contacts points out of the contacts and saving it into a variable called contact, and we're testing the variable contact multiple times, so the for loop goes through that every time. And then we have an opening and a closing bracket for the for loop, so this line of code is going to be tested every single time that we, or it's going to be tested once for every contact that we detect. And so inside of the opening and closing bracket, we have an if statement that says if vector3.angle contact.normal and vector3.up. Okay, so first of all, vector3.angle is a function inside of the vector3 class that's going to return you a float based on the angle between two vectors. So if you think about a vector 3, it's this like 3D grid with an x, y, and z, and then between point 0, 0 and the point that is the result of the 3 x, y, and z, you get a line that's pointing in a certain direction. Now let's say you have two vector 3s. You have a vector 3 here, and you line it up so the two vector 3s are on top of each other, and they're pointing in two different ways. Well, if you look at it, that creates an angle, and we can measure that angle. And that is what vector3.angle does. It will return you a float based on the angle between those two lines, or between those two vector 3s. So we're going to use that to measure what direction the ground is facing, or if it is too sloped for us to jump from. So if we have a flat surface, that's going to be pointing straight upwards, and we're measuring against vector3.angle contact.normal, and contact.normal is going to be the contact point, and the normal is basically, alright, so we have a plane. If you have a line coming perpendicular out of that plane, that is the normal. It's a vector 3 that measures pointing perpendicular away from that plane. So in the case of just a flat ground, that line is going to be pointing straight up. And we're measuring it against vector3.up. So basically vector3.up is 0, 1, 0, or just a vector 3 that points straight up. And since our ground is pointing straight up, and this vector3.up is pointing straight up, that's going to return 0 because it's the same angle. Whereas if we're on a ground and it's kind of sloped, it's going to be measuring around there against vector3.up, so that's going to return us a 45-degree angle. So depending on what we set max slope to, that might be less than the maximum slope, or it might be more than the maximum slope. Now let's take a look at the case of a ceiling. That normal is going to be pointing straight down, and then so when we measure that against vector3.up, straight down and straight up, that's going to be 180 degrees. So chances are we're going to be setting maximum slope to less than 180 degrees. I usually like to keep it around 45 because I can't imagine jumping on a ground that's a little bit more sloped than 45-degree angle. So we have if vector3.angle, and we're measuring between contact.normal, or the polygon that is attached, or the polygon that results in the collision, what's it's pointing at. So like I said, like for the ground, that'd be pointing straight up. And then we're measuring it against vector3.up, so anywhere in world space, just straight up. So that's going to return a float of the angle between those two vector 3s. And then if that is less than maximum slope, it's going to return true. So if it's true, we're going to set grounded to true. So basically, if our ground is, if we measure the angle and it's less than maximum slope, then it's going to return true, and it's going to say grounded, and if it's grounded, we can jump. Now our next problem is we have nothing that says when grounded is going to be false. So we got to make that code now, because if we don't change grounded to false at any time, Unity is never going to change it to false. So what would happen if we were to just add this, it would set it to true when we can jump, and then after that it would never go back to false. So you could still keep on, you know, triple jumping in the air or whatever you want to do. Alright, this next line of code is going to be a whole lot simpler than what we just went over. Basically what this is going to do is every time that there was a collision and then there is not a collision anymore, we're going to set grounded to false. So we have function on collision exit. So on collision exit is going to be called whenever there was a collision and then there isn't a collision, and it's going to be called once. And then we don't have anything inside of the parentheses because we don't need to save a collision variable because there's no longer a collision. And then inside of the opening and closing brackets, we're going to set grounded to false, because we need something to set grounded to false because Unity is not going to do that for us. And if grounded is never set to false, it's always going to be true, so that's going to mean we're always allowed to jump, and when you're like midway in the air, there's no feasible way to jump again, so we need that false to be in place. So hopefully that at least made some sense. I know it was really, really complicated, but hopefully it'll make more sense to you when we actually do it on the computer screen. So let's head over to the computer and actually get on Unity and do that like we do in every single episode. I'm sure you guys have figured out the pattern by now. So yeah, let's go do that. Alright, hey guys, here we are inside of Unity, and before we actually go into Unity, I want to take you over to the Unity script reference just to show you the collision variable and how this works. So as you can see, collision is a variable type, and it says collision information is passed to on collision enter, on collision stay, and on collision exit events. So basically it's a variable type that just has a whole bunch of variables within it to describe a collision. And the one we're going to be accessing in this code is contacts. And as you can see by these two square brackets right here, contacts is an array, and it is basically a whole bunch, or basically a list of variables of type contact points. So an array, like I said, it's a variable, but it's a list of variables. So if you want to access a very certain variable within inside of an array, you would put inside of these two square brackets either a 0 or 1, 2, 3, and so on and so forth. 0 is the first one on the list, so you write 0 for the first item, 1 for the second item, 2 for the third item, and so on and so forth. So then let's go over to contact points. And as you can see, inside of contact points, we have normal. So normal is a vector 3, and this tells us in which direction a polygon is facing, specifically the polygon that we have contact with. So let's go over to Unity. Actually, we need to go over to the code and to our player movement script that's attached to the player capsule. Now, before I do the code the right way, I'm going to show you the wrong way, just so I can show you why it's wrong, or partially wrong. So we have if input dot GetButtonDown jump rigid body dot add force 0, comma jump velocity, comma 0. Okay, and as you can see, I guess this is actually second take of a video and I forgot to delete these, but whatever. So let's just pretend that we just typed these now. So we have jump velocity, flow, and I ballparked it around 20. And then we have hidden in the inspector the variable grounded, and we have it set to false by default, because chances are, at least in the way the game is set up now, we have our capsule collider in the air, so it's not touching anything, so it's going to be false by default, or at least that's the way I have it set up. And then variable max slope, and I have that set to 60, and that is number of degrees. So as you can see, I have if input dot get button down jump. So if we press the jump button, as the key goes down once, or I mean as the key, first goes down, not as we're holding it, as the key first goes down. And let me just show you in when you go project settings, input, we have down here jump. This is one of the default keys, and it's jump, and it's the space bar. So basically, here we have positive position, space bar. Now let's go over horizontal, and you can see negative position A, positive position D. So when A is down, horizontal is going to be -1. If it's D, it's going to be +1. Or if they're both pressed down, it should be 0. So that's generally how the input manager works in the inspector. So let's go back to our code, and I think everything is in place. So let's save that and give it a little test run. And here we are, we're falling. Let's wait until we hit the ground. And jump. Seems to be working. Oh, one thing I actually did change. Let me go over player capsule. Instead of 20, I raised it all the way up to 800 in an earlier video when I did an outtake. So I had to take it up to 800 to actually make it a realistic jump. But as you can see, I can either jump from the ground or from the air. It doesn't matter. I can jump whenever because I have nothing defining whether or not I can stop jumping. It's just I can always jump. So let's add that code that says whether or not we can jump. So first of all, we need to press Shift 7. That was the key. That was the number I was thinking of in the video. And grounded. And we can just write grounded because grounded is a Boolean. So whether this is true or false, it's going to return it in the if statement. So let's go down here and actually define when grounded should be true. So we have function on collision stay, and the variables we want to save collision, and we want to save that of variable type collision. And now let's create our for loop. For var contact, and that's going to be of type contact point in collision dot as contacts. And let's create our opening and closing brackets and put our if statement in here. And we have if vector3 dot angle between contact dot normal and vector3 dot up. So the angle between those two, and if it is less than max slope, then we are going to execute this line, which is grounded equal true. So let's see how that works. So we're falling, and I'm hitting the space bar, and I can't jump. So let's see what happens when we hit the ground. We have successfully hit the ground, and I can jump. And wait to hit the ground again. I can jump again, but I don't have to wait until I hit the ground. I can just press space, and I can press space again, because we have nothing that says whether or not grounded should ever be false. So let's go back to our code, and this is actually really simple. We just write function on collision exit, and we don't need to put anything in the brackets because we're not accessing any information because we're just exiting a collision, and we write grounded equal false. So it doesn't matter whether or not we exit a collision when we're switching between two different game objects. See here, I will change up the map just a little bit so that we can actually test this out. And I want to rotate it and kind of make like a ramp sort of thing. And make it a little wider and a little longer, and there we have a ramp. So now I can switch between two different game objects without jumping, just as a test. So let's test the jumping. We can jump, and I'm hitting the spacebar, and we can't jump, and I can't jump until I hit the ground again. So that's pretty realistic, I think. Now, if we switch between two game objects, I should still be able to jump, because onCollisionStay will update every frame that I stay with inside of a collision. So right now I'm staying inside of the collision of touching the ground, and I exited a collision, and then I entered a collision into this big white block, and I'm staying in that collision. So grounded is returning true every frame that I do this. So I can jump up and down, and it seems to all be working. I can't jump when I'm not touching anything, and I can jump when I am touching something. So let me set the slope of this to more than 60 degrees just to make sure that maximum slope is working. So that seems like more than 60 degrees. I don't think there's going to be any feasible way for me to actually run up this. In fact, it's slanted the other way, so I'll go on this side, and I'm kind of on it, but I can't jump. So here I am, I'm sliding, I'm kind of stuck on the wall actually. When I hold it, the physics engine is actually creating friction, so I can't slide down it, but I can't jump either. So I would say that max slope function is working properly, so I shouldn't be able to jump off of a ceiling. Let's see if I can pull a Mario and hit my head against one of these. It's kind of slippery right now, so it's hard to... Okay, there we go. So yeah, there's no way to jump off of that either. So I would say our code is working. So you guys have just learned how to properly create a jumping function where you can only jump when it's realistic and you can't jump off of walls or ceilings. So there you have it. This has been Itsuki Tutorials. Until the next episode, I'll see you guys later. Keep making games.